Hi everyone, welcome back to my channel Mathematical Appetite. Today I am back with an amazing concept of engineering mathematics. I have already done a video on engineering mathematics 1, that is the introduction to nth derivative of the functions, that is the successive differentiation of the functions. So today it is the continuation video for that. Today we are going to intensively discuss about the nth derivative of logarithmic function. So whatever the functions we have log, such type of functions will be finding nth derivative. So before me getting into the concept, the people who are new to my channel, hi, this is Chiranjeevi. I am maths teacher and a motivational speaker. Yes, we'll get into the concept. So I hope you know what is nth derivative. If not, so just click the I button and go to my previous video of the introduction of nth derivative. I have given the detailed explanation of what is nth derivative, what is successive differentiation, and all the general forms. There are some standard functions. For that standard type, I have derived the nth derivative formula so that we can directly use the nth derivative formula and we can calculate the things. So for a revision before starting this problem, this concept, so I'm going to just revise a single line about what is nth derivative. So nth derivative is the thing, but for example, if we have d by dx of x to the power of n is nothing but nx to the power of n minus 1. Some derivative I have taken x to the power of n. If I again differentiate this that is d by dx of nx to the power of n minus 1, whatever the answer I will be getting, that is nothing but second derivative. I have done this all in my previous video. Next third derivative, next fourth derivative, it goes on like this, right? So whenever we differentiate like this, what happens? We'll be getting some general term, which means there is some pattern which is following here. So we'll take that pattern and we generalize the formula. So this is the thing happening. So let us see how to solve this. In general, today we are going to solve the functions, the problems based on the logarithmic functions, that is, it is in the form of log of ax plus b. So that is nothing but the general form, it is nth derivative I'm telling. So you will be having minus 1 to the power of n minus 1 the whole factorial, a to the power of n whole divided by ax plus b to the power of n. So this is the nth derivative of the function log of ax plus b. All the formulas, all the functions which are in this form, then we are going to use this formula, that is log of ax plus b is nothing but minus 1 to the power of n minus 1 the whole factorial, a to the power of n whole divided by ax plus b to the power of n. So this is the nth term, that is nth derivative formula for this form, where a and b are constant and x is the variable. Okay, so this formula will be using throughout to solve the formula, to solve this functions. Let us see. So it's all about the nth derivative. Yes, the first problem here we are going to see is, that is log of root of 4x square plus 8x plus 3. So this is the function. So here we have a function, we can find out log here. Yes, we can find out log here, but this function is not in the form of log of ax plus b, isn't it? So this function is not in the form of log of ax plus b. So our first work is to reduce this, make this function as simple as possible and bring it in this form so that we can apply this formula for the nth derivative. I hope you are understanding. Yes, so now this function I'm going to solve. Let us see one by one. First of all, if we observe this problem, that is log of root of 4x square plus 8x plus 3. So here, how to simplify? We have a square root here. So I'm going to remove the square root. How to remove square root? So that is nothing but the solution. So log of 4x square plus 8x plus 3 to the power of 1 by 2. Can I write like this? I hope you know this rule. The square root of x, this square root can be represented as 1 by 2. If at all it is third root, so then it can be written as 1 by 3. If it is fifth root, it can be written as 1 by 5. I hope you know the rules of exponents and the rules with respect to the surds, how this square root or the cube root or the fifth root is going to change. I hope you are understanding. So this rule I have used here because it is a square root. I have just removed this root, and since I have removed this, for this entire expression I will be having 1 by 2. That is the power. I hope you are understanding. Yes. Now what I am going to do, log of 4x square plus 8x plus 3 to the power of 1 by 2. This one I have changed like this. Now according to the property of the log. So here you can see there is a property of a log x to the power of a. If you take like this, log x to the power of a, that is nothing but a log x. So this is one of the property, logarithm property. Log x to the power of a. So before the log, if there is a variable and to that there is a power, so that power comes in front of the log and with log its variable. So here log x to the power of a can be written as a log x. This is log formula. Okay, so this we are applying here. What's going to happen? So that is nothing but, so this 1 by 2 will be coming here because I am applying this rule. So what happens? 1 by 2 into log of 4x square plus 8x plus 3. I hope everyone understood. Yes. Now what we are going to do, since here we have the quadratic expression, we are going to factorize it. Let us factorize that. Then we are going to substitute here. So similarly, let me follow the steps as it is. 1 by 2 into log of, how to factorize this? So 4x square, here we have 4 and 3, right? So this is the expression, algebraic expression, that is quadratic expression we have. 4x square plus 8x plus 3. Let me factorize this. How to factorize this? So 4 3s are, it is 12. For 12 it is 6 2s are, right? So 4 into 3 will be getting 12. It is 6 2s are 12. 6 plus 2 8. I will be getting this. So what I am going to do, I will be substituting 6x and 2x in the place of 8x. So what I will be getting, that is 4x square plus 2x plus 6x plus 3. Okay, so now I have substituted 6x and 2x in the place of 8x. So now what I am going to do, I am going to take common. Here 2 is common and also x is common. So 2 into 2 is 4, x plus 1 I will be getting here because 2x already it is out. See, remaining we have 2x plus 1 plus here what is the common? We have 3 as common, right? So 3, it is 2x plus 1. So again I am going to take this 2x plus 1 as common. So I will be getting 2x plus 1 into 2x plus 3. So this is how we factorize a quadratic expression. So this rule we have used here. First I have used this rule, and now what I am going to do, here whatever the quadratic expression I have, I am going to factorizing it. Now it is with different factors. Now instead of writing 4x square plus 8x plus 3, what I am going to do, directly I am going to write the factors, that is 2x plus 1 into 2x plus 3. Okay, I hope you are understanding. Now that is equal to, what happens, we have 1 by 2 into, you know again a formula, that is log of AB can be written as log A plus log B. Log of A plus B, so this is the factorization what I have done. Okay, so here again I am using a formula, that is log of AB is nothing but log A plus log B. Similarly here log of, if I consider this as A and this as B, what happens, that is going to become 1 by 2 into log of 2x plus 1 plus log of 2x plus 3. Okay, So now we got this. Now if you observe the expression, it's a very beautiful expression. Whatever the function we had like this, now I have converted in the form of log of ax plus b. We have got that form, right? Log of ax plus b. Now easily I can apply the nth term, that is nth derivative formula. What is the nth derivative formula? That is log of ax plus b is nothing but minus 1 to the power of n minus 1. So n minus 1 to the, it is factorial n minus 1 factorial a to the power of n whole divided by ax plus b to the power of n. So this is the formula we have, that is log of ax plus b is equal to minus 1 to the power of n minus 1 n minus 1 factorial a to the power of n by ax plus b to the power of n. Now similarly same thing I am going to substitute here. So that is equal to 1 by 2 into, so here if you take, here I have log of ax plus b, right? So here a takes the value of 2 and b takes the value of 1. Here also a takes the value of 2 and b takes the value of 3. Okay, so same thing we will be applying here. See, because we don't know the n, directly we will be putting that, that is minus 1 to the power of n minus 1 the whole factorial. So a we have here, a is nothing but 2. I hope you are understanding. So it is 2 to the power of n whole divided by ax plus b to the power of n, which means ax plus b is nothing but 2x plus 1. So 2x plus 1 to the power of n plus, again it is in the form of log of ax plus b. So 2x plus 3, it is nothing but ax plus b with respect to this. So again I am going to substitute, that is minus 1 to the power of n minus 1 factorial. A is again 2 here, so that is 2 to the power of n. I hope you are understanding, whole divided by, so it is 2x plus 3 to the power of n, because ax plus b is nothing but 2x plus 3 here. Okay. So now we have substituted the formula of nth derivative of the form of the function log of ax plus b. So here the same type we have deduced first and then we have written this. Now we'll make it the simplest form. So here we have 1 by 2. What is common? We have minus 1 to the power of n minus 1 is common, both. And also n minus 1 factorial is common. Also 2 to the power of n is common. What is the remaining? It is 1 by 2x plus 1 to the power of n plus 1 by 2x plus 3 to the power of n. Okay, so this is the thing. Finally, what we can write? Here I have 2 to the power of n and here 2. So that I can combine these two, because we have exponential a to the power of m by a to the power of n is nothing but a to the power of m minus n. That one I will be doing here. So altogether I will be getting, so it is 2 to the power of n minus 1. This I am getting because this is 2 to the power of n divided by 2. I am taking together, minus 1 to the power of n minus 1 factorial and into this one 1 by 2x plus 1 to the power of n plus 1 by 2x plus 3 to the power of n. This is our required solution, which means, so this is the required solution. So this is the nth derivative of this function. So that the first derivative you can derive it, you can differentiate it. Okay, the second you can differentiate it. Third you can differentiate. Fourth you can also differentiate, but becomes a little bit hectic, right? So when you have nth derivative formula, what happens if I need the 100th derivative of this function log root of 4x square plus 8x plus 3? Then what we are going to do? Yes, simple. We have already deduced, right? Just apply 100 in the place of n, 100, and you solve. So that will be equal to the 100 times the derivative. That is the 100 times what you are differentiating, you will be getting the same answer. How easy it is, how fantastic and amazing it is. Yes, we'll go to the second problem. If you look into this problem, so it seems to be difficult, but it is not actually difficult. If we have nice basics with respect to mathematics, it's not a difficult problem. So in the previous problem, I took directly log, but it was not to the base 10. But here, it is to the base 10. So first we'll convert this complete function to the base e, then we'll start solving, and we'll make that into the form of log of ax plus b, and we'll apply the nth derivative formula. So here, if we get this log 10, we know what is the formula we know. That is, we already know that log of log x to the base 10 is nothing but this. If we want to convert in the form of e to the base e, so it's going to become log x to the base e by log 10 to the base e, isn't it? So this is the formula we have. Okay, so log x to the base 10 can be converted in the form of e like this. That is, log x to the base 10 is nothing but log x to the base e divided by log 10 to the base e. Just this two gets divided with the base e. Hope you are understanding. Yes. Now similarly here, in the place of x, I have this complete thing within the root. I will be doing it, and I will be first converting it in the form of base e, log base e. So that's nothing but, so we have log base e is nothing but log of, what is that, x, right? So it is root of 3x plus 5 to the power of 2 minus 3x whole divided by x plus 1 to the power of 6 to the base e whole divided by log 10 to the base e. I hope you are understanding. For this complete thing, I have applied this formula, that is log x to the base 10 is nothing but log x to the base e divided by log 10 to the base e. Yes. So this thing happened. Okay, I have first converted. So we have first converted this log base 10 to log base e. It's over. Now what we are going to do, I am going to remove this. So what I am going to do, I am going to take this 1 by log 10 to the base e one side, this, and this one I am going to again convert here, because here I have root, right? So that's going to become log to the base e of 3x plus 5 the whole square into 2 minus 3x whole divided by x plus 1 the whole power of 6. So to the power of 1 by 2 I will be getting. Okay, because this square root, it is getting converted to 1 by 2. I said in the previous problem. Okay, so next step, what I am going to do here. So according to the formula, log of, so log x to the power of a is nothing but a log x. This is the formula we have, right? So this formula I will be applying here. So what we will be getting? It is 1 by log 10 to the base e and 1 by 2 into log of 3x plus 5 for the whole square 2 minus 3x whole divided by x plus 1 to the power of 6. I will be getting this. Okay, just what I have done, I have applied this, that is log x to the power of a is nothing but a log x. This power comes before the log. I have written that. Now since it is in the form of log, we have the formula. What is log of ax or log of ab? Log of ab is nothing but log a plus log b, right? Log of ab is nothing but log a plus log b. Also log of a by b is nothing but log a minus log b. Okay, so this is the formula we have. right? Log properties. Log of a into b is nothing but log a plus log b. Log of a by b is nothing but log a minus log b. This formulas I'll be applying here. So already we know this formula, log of x to the power of a is nothing but a log x. So similarly I'll be doing for this one and directly I'll write it. Or otherwise, let me first apply the log. So log 10 to the base e into 1 by 2 into what happens? So here first let me apply this formula. Log of 3x plus 5 the whole square. Let me write that formula afterwards. Okay, so I am just splitting this log of AB, right? So we have, I am going to split this plus log of 2 minus 3x. I am writing here because log of A into B is log of A plus log of B minus log of x plus 1 to the power of 6. I hope you are understanding, because here I have applied the formula, that is log of A into B is nothing but log A plus log B. Log of A by B is nothing but log A minus log B. Okay, so here I have applied the formula. Log of AB is nothing but log A plus log B. Log of A by B is nothing but log A minus log B. So here it was in the product. So I have just added log of 3x plus 5 the whole square plus log of 2 minus 3x minus. So because it is in the denominator, I will be writing this formula I am applying here, minus log of x plus 1 to the power of 6. I hope you are understanding. Yes. Now directly what I will be doing again. So that is equal to 1 by log 10 to the base e, 1 by log 10 to the base e, 1 by 2 I will be taking, and here what I will be doing, since we have log of 3x plus 5 2, I will be applying this form, that is it becomes 2 log 3x plus 5, that is it becomes 2 log 3x plus 5 plus what happens? So here it is as usual, that is log of 2 minus 3x minus this one we have. So here it is power to the 6. So I will be applying this. So it becomes 6 log x plus 1. So it is going to become 6 log x plus 1. Okay. I hope you are understanding. Now we know the formula. So what is the formula? So we know the formula, that is the nth derivative of the form log of ax plus b is nothing but minus 1 to the power of n minus 1, n minus 1 the whole factorial, a to the power of n whole divided by ax plus b to the power of n. I have this form. This is, what is this? This is nth derivative. So this nth derivative I have already derived in my previous video. You can just watch that video. So it is nth derivative, that is log of ax plus b is equal to minus 1 to the power of n minus 1, n minus 1 the whole factorial into a to the power of n by ax plus b to the power of n. So now I am going to apply here, because here we have the form of log of ax plus b. Yes, simple. So that is equal to 1 by log 10 to the base e, just 2 I can write 1 by 2 log 1 by 2 log 10 to the base e. Now what happens? 2 into log ax plus b, in this form we have, that is minus 1 to the power of n minus 1, n minus 1 the whole factorial, but here a is nothing but 3. So 3 to the power of n whole divided by 3x plus 5, it is ax plus b, 3x plus 5 to the power of n. So plus, again here we have log of 2 minus 3x. So here we don't have any coefficient, directly you can apply this formula, that is minus 1 to the power of n minus 1, n minus 1 the whole factorial Here a is the thing, but 3 minus 3. See, here it has been interchanged. It should be in the form of log of ax plus b. Here a is the thing, but minus 3. Be careful, it has interchanged. So you can write this as minus 3x plus 2. So here it is minus 3 to the power of n whole divided by, we have, so 2x minus, 2 minus 3x whole to the power of n minus, so minus this one we have 6 into log of x plus 1, which means a is the thing, but 1, right? It is ax plus b. So I will be applying this formula, that is minus 1 to the power of n minus 1, n minus 1 the whole factorial. Here a is the thing, but 1 to the power of n whole divided by x plus 1 to the power of n. Okay, so this is the solution. We are finding the nth derivative of this function. So that is equal to, what's going to happen? Okay, so just you can take out common, that is we have 1 by 2 log 10 to the base e. What all the common you have? You have minus 1 to the power of n minus 1 is common, n minus 1 the whole factorial is common. That's it. So there is no other things are common, right? So directly you can write now, that is 2 by, so 2 by, what is remaining here? It is 2 into 3 to the power of n. Even 3 to the power of n is remaining here, right? So we can write 3 to the power of n by 3x plus 5 to the power of n, okay, plus here minus 1, this goes, here we have minus 3 to the power of n by 2 minus 3x to the power of n minus, we have 6 into 1 to the power of n by x plus 1 to the power of n. So this is the required solution. You can further take this 3 to the power of n. Here also you can take 3 into 2 and you can take that common. It's not necessary. If at all you want, you can take this as 3 into 2 and you can again take that as common. Okay, so or you can keep it as it is. This is the simplest form. I have already taken everything common. So this is the required solution for this function, log to the base 10 of root of log of 3x plus 5 the whole square into 2 minus 3x by x plus 1 the whole to the power of 6 to the base 10 is nothing but the nth derivative of this function is nothing but this one. So if you want to find out the 56th derivative of this function, just take this answer, substitute 56 in that place, then you will be getting the 56th derivative of this function. I hope you understood and you enjoyed. This is the way we find the nth derivative of a function. In the next video, I'll be coming up with the nth derivative of some other types of functions. So, till then, be mathematically inclined, enjoy mathematics, and I'll be coming up with an interesting and a beautiful concept in the next video. Thank you. Have a great day.